Hi guys, this is me again. My name is Joseph AGK Oji. This is another lecture in my statistics series. Today we will be discussing two types of probability: the empirical probability and the subjective probability. In my previous lecture, we covered the classical probability. But today, we'll be discussing the remaining types of probabilities, which are the empirical and the subjective. Let us begin with the empirical probability. I'm very sure you're going to enjoy this lecture. I'm going to make it as simple as possible for you so that by the end of this lecture, you'll be able to handle a lot of probability questions. Okay? So let's begin. The empirical, or what we call statistical and sometimes relative frequency probability. So in this method, unlike the classical probability where we already know the sample space, in empirical we don't know the sample space, which means that we have to estimate the sample space by ourselves using this formula here. So let's say that the event is E. The probability of event E happening is the frequency of event E divided by the total frequency. So that frequency of event E we represent it by the letter F, and the total frequency we replace it, or we represent it with the letter N. Okay, so again here we estimate the sample space by ourselves by conducting some kind of probability experiment, or by using what we call a relative frequency and then applying this formula after that. Let us see how this works. Look at this example on the screen. It says here that this company is conducting a telephone survey of randomly selected individuals to get their overall impression of the past decade, that is 2000. So far, 1,504 people have been surveyed. The question here is said, what is the probability that the next person surveyed has a positive overall impression of the 2000? So these are the responses we have here on the table. Positive responses: 406 people say have a positive response. For negative, we have 752 people. For neither, 318. For don't know, 30. Now, because we don't know the sample space, so we have to estimate it by ourselves by adding all this. That will give us our sample space right here. See? With this, we are ready to answer the question, which is to find the probability that the next person surveyed has a positive overall impression of the 2000. Okay? So let us solve it now. So how many people answered positive? 406 out of 1,504. Therefore, the probability of that the next person surveyed has a positive impression will be 406 out of 1,504 people. That is what we have here. See the positive right here. See the positive. Now, so that we have it as 406 out of the overall total. See here, which is 0.270. Like I said in my previous lectures, we can write the answer to a probability question as a decimal, as a fraction like this, or as a decimal, or as a percent, which means that we can also say that we have 27% chance. There is 27% chance that the next person will have a positive impression of the year 2000. Okay. So that is how we get the empirical here. So we plug this on the calculator. Put this one first. I can even show you how to put it on the calculator. Look at my calculator right here. I have 406. Wait just a minute. Okay, 406. So you have 406. Okay, divided by, see, I'll have 1504. 1504. See, and that gives us 0.269. So if when you round it, you give it 0.27 right here. Okay, so we have answered the question. That is how we answer empirical probability questions. We are going to do one more example, because the more example you do, the more you understand the concepts better. Okay. Now let's look at this example here. It says hospital records indicated that maternity patients stayed in the hospital for the number of days shown here. 3 days frequency. Those that stayed 4 days, there are 32 of them. Those that stayed 5 days, there are 56 of them. 6 days, 19 of them. 7 days. Then the question says here to find these probabilities that the patient stayed exactly 5 days. B says that the patient stayed less than 5 days. C said that the patient stayed at least 6 days. To be able to answer this question, we need to find our sample space first, which means that let us go back to our table. So since we don't know the sample space, we get it by adding all this number to get 127. So this becomes our sample space right here. With this, we are now ready to answer the question. The first one says that the patient stayed exactly 5 days. How many patients stayed 5 days? We have them right here. 56 patients stayed 5 days. So the probability that the patient stayed exactly 5 days is 56 out of a total of 127, which we have here. The probability of 5 days is 56 out of 127. Now, when you plug this in the calculator, which I can also show you here, I have 56 divided by 127, which is this one here. Okay, you will see the answer at 0.4409. That when you round it, you get 0.441. Or you can also say there is 44.1% chance that the patient stayed exactly 5 days. Okay. The next one is that the patient stayed less than 6 days. Okay. Now, less than 6 days does not include 6 days. It means that less than 6 days means from, let me show you on the table. So this is 6 days, right? So that less than 6 days means those that stayed 5 days plus those that stayed 4 days and 3 days. So less than 6 days does not include those that stayed 6 days. It's those that stayed 3, 4, and 5 days. So that the probability of the patient staying less than 6 days means the probability of staying 3 days plus the probability of staying 4 days plus the probability of staying 5 days. Now for 3 days, how many stayed 3 days? From the table, we have 15 out of 27 patients stayed 3 days. And we have it here. 15 out of 15 out of 27 patients stayed 3 days. How about 4 days? Here, we go to the table. How many stayed 4 days? 32 out of 27. We have it right here. I wrote that. Let me make sure I have it right. It's actually 32. So here is it should be 32. Let me correct it right away because it is 32. We're gonna have it here as 32. Oh, I think I have it correctly. I just switched it around. Okay, I think it's good. So 4 is 32 out of 127, which is oh yeah, I think I have it. Just a minute, let me correct it. 32 out of 127. Okay. All right. Then how about 5 days? 5 days. From here, we have 56 out of 127, which is right here. Okay. Now, having done that, we can now get our answer. From here, we have the first one is 32. I put the 32 is right here. Let me make it simple. 32, 15 plus 32 plus 56, and that gives us 103 that we have here. You can see right here on the calculator, 103. Have it here as well. So when you divide it by 127 here, have 127 point 811. See, 811 right here. So there are 81.1% chance that the patient stayed less than 6 days. Okay. Now the last example is the probability that the patient stay at least 6 days. At least 6 days means 6 days or more. Okay. So look at here. 6 days. So at least 6 days means 6 or more. That means 6 and 7. So that probability we have it here. For 6 days, we have 19 out of 127, which is right here. 19 out of 127. Okay. Plus for 7 days is 5 out of 127, which is right here. 5 out of 127. So when you add it, you get 24 out of 127, giving us 0.189 or 18.9%. So that is the probability the patient stayed at least 6 days. So this basically summarizes the empirical probability. Next type of probability we look at is the one that we called the subjective probability. Okay. Just 1 minute. Let me put it here. Okay. The subjective probability, let me put it here. I have an example here. Subjective probability. In this type of probability, we don't, it is based on what we called educated guess. That's why I did not provide a separate page for it. We don't use it much because it is subjective. I'll give you an example of the subjective probability, what it means. It says that it is based on educated guess. Give me 1 minute, let me put it in. Okay. The subjective probability, subjective probability is based on, as the name implies, on educated guess. Educated guess, assumptions, etc. Okay, let me put it this way. So that's why we call it subjective, because it is based on educated guess assumptions. And I'll give you an example. A doctor might say that on the basis of his diagnosis, that there is 40% chance that the patient will need a surgery. So because it is subjective and based on educated guess, the doctor might be right or wrong. I mean, I have seen a lot of people where the doctors say that they need a surgery or that they needed a surgery, but in the end, they never had the surgery and yet they are fine. I have also seen people that the doctor said that they will not need a surgery, but eventually they did need a surgery. Another example is this. During this coronavirus pandemic, doctors were saying that young people don't have a lower chance of, they don't have the disease. They can't contact the disease. But our experience these past few months have shown that actually young people can also become sick with coronavirus. So because this kind of probability is subjective, we don't normally use them. So we're not going to spend time on them because they are subjective. We want to calculate probability, we use only the classical method and the empirical method. Okay? Let's answer a few questions here now based on what I have just explained. It says, classify the statement as an example of classical, empirical, or subjective. The question here says, the probability that you will get a flu is 0.2. I mean, 20%. Well, this is subjective because it is probably based on an educated guess. Okay? How about this one? It says to classify this statement as an example of classical, empirical, or subjective probability. Now, the question here is that it says the probability that a voter choosing at random will be younger than 40 years old is 0.34. Well, this one is probably based on a survey. So we conclude that it is empirical. It is empirical probability. Okay? How about this? the probability that Joy wins 1,000 ticket raffle with one ticket is 1 out of 1,000. So this one, we know the sample space to be 1,000. In this case, we say that it is classical since we now know the sample space. Okay. Now this ends our lecture on classical, empirical, and subjective probabilities. In the coming lectures, I will introduce you to some of the basic rules of probability. Meanwhile, don't forget to subscribe to my channel so that you will receive notifications when there is a new lecture available. Thank you guys for listening. Again, my name is Joseph Ejikoji. Bye-bye. Okay.